Hello everyone, how are you? I hope everyone are doing good. I came with a video where we will solve an important and an interesting numerical problem related to network analysis or circuit theory. I will read out the question for you. In the circuit shown in figure, E1 and E2 are two ideal unknown EMFs. So here E2 is there, here E1 is there. These two are unknown EMFs. Some currents are shown. Okay, if you observe that here 2 amperes of current shown, here 3 amperes of current is shown, and potential difference appearing across 6 ohm is 10 volts. So between these two points the potential difference is given as 10 volts. Now what we need to find is here the options are given. We need to check which option is correct. So the unknown EMF E2 is 54 volts. Current in the 4 ohm resistor is 5 amperes. The resistance R is equal to 9 ohm, and the unknown EMF E1 is 36 volts. Okay, so let me draw the circuit first and then we will see whether we can solve it in a easy way or else. Let me check it first. Is the circuit given in the problem. First, let me find what is the current flowing through this 4 ohm resistor. There are actually two 4 ohm resistors. Through one 4 ohm resistor, 3 ampere current is flowing. It is already given in the question. Now we need to find the current flowing through this 4 ohm resistor. Okay. So in order to know that, what I'm trying to do is, here the voltage across AB is given as 10 volts. So find the current through 4 ohms. I'm just considering these two as parallel, 6 ohm and 3 ohm as parallel. If you replace that with a single resistor, the nodes will not be removed. Therefore, the circuit can be redrawn like this. And we must know what is the equivalent resistance between 6 ohm and 3 ohm. 6 ohm is parallel to 3 ohm. Therefore, it gives rise to R1 into R2 by R1 plus R2. So it is 18 by 9, which is equal to 2 ohm. So in between the terminals A and B, an equivalent resistance of 2 ohms will be there. So the circuit will be modified as, so if you want to find the current through 4 ohm, it is same as the current through 2 ohm, because if you observe in the circuit diagram, 2 ohm and 4 ohm both are connected in series. Therefore, if I find the current through 2 ohm, so current through 2 ohm is same as current through 4 ohm. It is equal to 10 by 2, which is equal to 5 amperes. Therefore, the current through 4 ohms is also 5 amperes. So let me change the color for currents. So this is the current. So through 4 amperes, the current flowing is 5 amperes, and through 2 ohms also the current flowing is 5 amperes. Okay. Now, first, second option is correct according to given options. Second option, the current in the 4 ohm resistor is 5 amperes, so this is correct. Okay, now we need to check the remaining three options. In order to check that, let me consider this as a ground node for simplicity, and I want to find the potential at A, right? So the current flowing through 2 ohm and 4 ohm is 5 amperes. Therefore, let me consider this as VAG, or the node at, sorry, the voltage at node A. It is equal to, so the current 5 amperes multiplied with the total resistance is 2 plus 6. So, sorry, 2 plus 4. So 5 into 6, 30. So the voltage at node A is 30 volts. Okay. Now, let me find this node voltage also. Let me give a name for that. Let me consider this as D. Okay. So what is voltage at node D, which is VDG or VG? Sorry, VD. VD. Now, what is this value? It is equal to, so the current is 3 amperes multiplied with 4 ohms. Therefore, the voltage is 12 volts. Okay. So at this node, the voltage will be 12 volts. Okay. So from here, the current entering to this node is 5 amperes and the current from here is 3 amperes. So there will be total of 8 amperes flowing vertically towards the middle branch, which is 3 ohm. Okay. Let me redraw the circuit to avoid the confusion. Okay. So this we want to find now. How can I find the current through this resistor is given as 2 amperes, and we know the potential at this point at A and the potential at the node D. Okay. So the current through 2 ohm, sorry, current through R ohm is equal to 30 minus 12 by R, and this current is given already 2 amperes. Therefore 30 minus 12 by R is equal to 2 amperes. It implies R is equal to 30 minus 12 by 2. 30 minus 12 is 18. 18 by 2 is 9 amperes. Therefore the current 9 ohms, sorry. So we are just finding the resistance value. So this resistance 9 ohm. If you go through another option which is given in the problem, so here if you observe third option, C, the resistance R is equal to 9 ohm, so it is also correct option. Okay. Now our duty is to find E1 and E2 values. Okay, let's jump into that process. So this is E2. If you observe in the diagram, E2 is obtained by subtracting, or let me do uh, the voltage between A and C. So VA minus VC is equal to E2 from the diagram. Okay. So from the diagram, the positive terminal of cell E2 is connected to node A and negative terminal is connected to node C. That's why VA minus VC is equal to E2. Now, what is VA? We already know that it is 30 minus. Actually, VC is a negative voltage because the current is flowing in opposite direction, vertically upwards. So 8 into 3 is 24 volts. So VC is minus 24 volts. Okay. So why we took negative? Because this is negative here and this is positive here, because current is entering vertically upwards. So you have a negative voltage at node C and its value is minus 24. Therefore it is equal to E2. It implies E2 is equal to 30 minus of minus plus. So 30 plus 24 is equal to 54 volts. Okay. So let me go through the options. See, the unknown EMF E2 is given as 54 volts. It is also correct option. Okay. Next, the last part of our video, which is the finding E1. Okay. So from the diagram only what we can say is E1 is nothing but the difference between, the difference between the node D and node C. So VD minus VC is equal to E1. What is VD? It is 12 minus of minus 24 is equal to E1. Now E1 is equal to 12 plus 24, which is equal to 36 volts. Okay. So let me check it once. Check the last option. Yeah. So the unknown EMF E1, it is 36 volts. So E1 is 36 volts and E2 is 54 volts, and the current flowing through another 4 ohm resistor is 5 amperes, and the resistance, unknown resistance value is 9 ohms. So all are correct in this particular problem. Okay, so